Hey everybody, day 18 of math time. Yesterday we talked about how slow things went with the school bus and the snail. Today, canines and cars. This type of dog is called a greyhound. The fastest dog in the world is the greyhound, and it can run 45 miles per hour. When running, greyhounds seem to fly through the air. You couldn't keep up with one if you took it for a walk. Here is a solar powered car, and we have one here at the University of Missouri, and they race it every year. Sometimes they've won, sometimes it just breaks down. It looks a whole lot different than a normal car. Some cars are powered by the sun, and college students have built one that goes 90 miles per hour. That speed is twice as fast as a Greyhound's. This kind of car will be able to go even faster in the future. But they look really funny, and they don't work at night. Remember how they said you can't put a picture of the right size dollar bill in here and it can't be green, so it's always black and white. So here's on a large picture of a dollar bill, and there's George Washington on the front, and there are lots of pictures on the back, and it says, United States money, in God we trust. So here's what's on the dollar bill. This mark tells you which Federal Bank Reserve issued the bill. So the big circle here, that tells you which bank it was minted at, and there's different letters. So you should maybe go see if Mommy and Daddy have some dollar bills and see how many different letters you can find. Although the bills are printed in the U.S. Bureau of Engraving and Printing in Washington, D.C., they're issued from different Federal Reserve banks. Federal Reserve banks and their codes that indicate their districts are: Boston is A, New York is B, Philadelphia is C, Cleveland is D, Richmond is E, Atlanta is F, Chicago is G, St. Louis is H, Minneapolis is I, Kansas City is J, Dallas is K, and San Francisco is L. So since this has a K on it, this would have been from Dallas. But hey, Grandma's home city, St. Louis, has them, and Claire and Walter's home city, Minneapolis, also has a Federal Reserve Bank that issues money. This is the serial number of the bill, and each one has a different number on it. There's now an app out there, and some people write, where in the world is George, or something like that, and you can log in the serial number. You can see how many different people have used that same dollar bill. It's kind of funny. And then each one has the signature of the current treasurer. So dollar bills that are older have a different signature than the more current ones. On the back is the Great Seal of the United States, and the unfinished pyramid symbolizes growth. The eye represents the watchful gaze of God. There's a number in the series identifies, it shows the date when the bill design was first used, and a new design may only mean that the name of the treasurer has changed. So this says series 1988A. So you can tell how old the dollar bill is. The eagle symbolizes the 13 original colonies of America. There are 13 stars above the eagle's head, and 13 arrows in one claw, and an olive branch with 13 leaves and 13 olives held in the other claw. So that's a little bit more about our money. All right, estimate. We've looked at tens and hundreds and 1,000. So once you look, we've got googly eyes this morning. How many googly eyes do you think are on this page? Do you think a good guess would be 100? Maybe 200? They're in pairs. We could start counting by pairs and skip count. 2, 4, 6, 8, 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, maybe 130. I don't really want to count them. I just want to have a guess. If I have 10 grandchildren and I want to give everybody about the same number of eyes, if there are about 130 and there are 10 of you, then everybody would get 13 pairs. You could make a lot of fun projects with 13 pairs of googly eyes. Grandma probably does have that many googly eyes at the house in the Creative Crate. Oh, joy. You're going to love this next page. Rubber bugs. How many do you think are there? Do you think there are more bugs or more googly eyes, or about the same? I think it looks about the same. And Grandma probably would have said there are about 150. And we sort of rough counted and said, 130. 150 would have been close. I'm going to say there's about the same number of rubber bugs as googly eyes. Joy, what can we do with 150 rubber bugs? Count to 1,000,000. This is by Jerry Pilato, and it's illustrated by Rob Bolster. And he's worked a lot with Jerry Pilato as the illustrator. And on the back, we have place value. When the first number is our ones, then tens, hundreds, thousands, 10,000s, 100,000s, 1,000,000. And we've used the counting by 10 song to count to 1,000,000. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 70,000, 80,000, 90,000, 100,000. And we can count by 100,000s to count to 1,000,000. 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000, 800,000, 900,000, 1,000,000! So we can skip count and count to 1,000,000 pretty fast. But getting to 1,000,000 regularly would take a long time. How many pieces of candy do you think there are? We've just been estimating. I'm going to say there's about 10. But it's a small enough number, then we can actually count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there is one Earth for us to live on. But if you can count to 10, you can count to 1,000,000. Because our system is based on 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers. I have 10 rocks. And each rock is represented by a number. So when I count them, I have to make sure that I actually touch and don't go too fast and say numbers before I've touched something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I'm not careful with my touching and counting, then I get off. And that's not good. We have place value. When you write a number, the order they're in tells you something. It's like reading, only we kind of read the opposite way. So the first number, all the way on this side, is always the ones. And I say them 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the second number is always groups of 10. How many groups of 10 do you have? Did you have 10 dimes? Did you have 9 dimes? I had 9 dimes and 5 pennies. So I had 95 cents. Next is 100s, then thousands, 10,000s, 100,000s, up to 1,000,000. So this number is 2 because there's only one of them. and it would mean I just have 2. This number is 54. I have 50 of something and 4 more. 54. This number is 670. I have 670 of something. And I could go count it. Uncle Peter has lots of big bins with big buckets of screws and nuts and nails. And he's supposed to know how many are in those buckets. About. And he knows that the one bucket this size would have like 500 screws in it. But this little bucket here might have 1,000 nuts or washers. But he's supposed to be able to count them for inventory at the end of the year. Oh, joy, there you go. 10 ladybugs. And look, they have different numbers of spots on it. Here's 1 spot, 2 spots, 3 spots, 4 spots, 5 and 6 and 7 and 8 and 9 and 10. 10 ladybugs with different numbers of spots. Whoa! 100. 100 jelly beans. And we can do our skip counting by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. $100 is a lot. 100 individual pieces, 10 groups of 10. It's not as easy to count the groups of 10 when they're all in a pile like that. Whoa. 1,000 is 10 piles of 100. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. It's a big number. $1,000 ants. I'm pretty sure every time ants come to a picnic, they bring 1,000 of them. This isn't as easy as to count. I don't have the groups of 100 separated out. But I'm going to assume the illustrator took the time to do that and counted. Whoa! Now I have 10 piles of 1,000 ants. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. I could still count them if I had to, but it would take me a long time to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'd be here a really long time. I think it's longer than we want to read this one. 10,000. 10,000 people running a race. It's a lot of people. Last night when Mizzou played its basketball game, there were 17,000 people at the basketball game watching. So when I start talking about 100,000, that would have been like 5 or 6 basketball arenas full of people. 100,000 people is about how many people live in the city of Columbia. The city of Columbia has about 120,000 people in it, plus the 30,000 college students. It's a lot of people. Of course, Minneapolis has many more because it's a much bigger city. So, 10,000. To get to 100,000, I count the groups of 10 of those. 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 70,000, 80,000, 90,000, 100,000. I could also multiply 10 times 10,000 to get to 100,000. $100,000 people in a football stadium. Mizzou Stadium only holds about 75,000, but the University of Florida Gainesville holds close to that. But that would be like 10 football stadiums full of people to get to 1 million. And there are a few Sundays a year where there are about that many people in a football stadium across our country. Of course, there's usually more people watching it on television. So, 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000, 800,000, 900,000, 1 million people in the football stadiums. Well, during World Cup time, there were probably that many people easily watching things. 1 million is a really big number. Million grains of sand is probably the easiest way to find a million things pretty fast. And one scoop probably has about 1 million grains of sand in it. There's our big Earth. This book started with one Earth, this planet we live on. There is only one Earth. But if you look up at the sky on a clear night, you can see 1 million stars. 1 million. Have a good day, guys.